You're listening to EUAudio. Listen, learn, lead. Concorde, an inspiration. Using technology from Concorde to develop new high-speed aircraft. 2019 marked the 50th anniversary of Concorde's first flight. It took off from Toulouse, France, for its first test flight on March 2, 1969. Although no longer in operation, the development of Concorde led to the progression of pioneering technologies, which still help today's aerospace engineers develop new, high-speed aircrafts. Developing an aircraft capable of supersonic transport presented the engineering team with several challenges to overcome. For example, the aircraft required extremely high power and fuel to counteract the considerable friction incurred at high speeds. The engineering team designed the aircraft to overcome these challenges, meaning Concorde could reach 1,354 miles per hour and fly from New York to Paris in under 3 hours. For 27 years, it transported passengers at over twice the speed of sound. However, the expense of its operation, the crash of 2000, and the September 11th terrorist attacks contributed to the decision to retire the aircraft in 2003. Although no commercial supersonic travel has taken Concorde's place, the technology that allowed it to break the sound barrier should not be forgotten. Concorde was the first aircraft to use fly-by-wire flight control. Instead of operating via cables and push rods, physically connecting the aircraft's wings and surfaces to the pilot's controls, fly-by-wire systems converted the pilot's instructions to electrical signals that controlled actuators. Fly-by-wire systems are more lightweight than manual systems because they do not require any mechanical components. They also optimize trim setting, which reduces drag, helping aircraft to reach top speeds. Aircraft are designed with aerodynamics in mind, with the aim to reduce drag. However, the highly streamlined nose, originally designed for Concorde, actually obstructed the pilot's visibility. To counter this, Marshall Aerospace in Cambridge developed a droop nose section. This configuration can switch between a horizontal streamlined formation for minimizing drag and a drooped formation for better landing visibility. A droop nose system was also used in the Tupolev Tu-144, the only other supersonic aircraft ever to have operated. It is likely to be an important feature in future high-speed aircraft. An early prototype for Concorde had a short wingspan to reduce drag, but this design also reduced the aircraft's lift. To overcome this, the team incorporated triangle-shaped delta wings to increase the lift by producing strong vortices on their upper surfaces at high angles of attack, lowering the air pressure. The engineering team also faced a challenge matching the centre of pressure with the aircraft's centre of gravity. Normally, this is achieved by shifting the wing position, but because Concorde's delta wings spanned the entire length of the fuselage, this was not possible. As a result, the only suitable shape was the ogival wing, shaped like an OG, a kind of sigmoid curve. Concorde's maiden flight on March 2, 1969, lasted just 27 minutes before strong winds forced it to land. Nevertheless, the aircraft later broke numerous world records, including the fastest flight from John F. Kennedy Airport to London Heathrow Airport in just 2 hours, 52 minutes and 59 seconds. Although Concorde's retirement came much earlier than was hoped, the discoveries and inventions of those who designed and developed it can be used today to inspire the design and production of new high-speed aircraft. In a rapidly developing industry, aerospace engineers can look to the past as well as the future to help them develop innovative, creative designs. EUAudio is brought to you by EU Automation,